Alright, welcome to your homework about light. Most light waves are formed as a result of the vibration of, there's different ways you can answer this. I think you could say electrons, you could say atoms, you could be more general and say charged particles. Charged particles, any one of these answers would suffice as far as I'm concerned. To answer this next one, we want to know, let's see, what is the wavelength? So we're looking for lambda, so we're going to use the wave equation. So we're going to say the frequency of oscillation equals the velocity of the wave divided by the wavelength. And so we're going to substitute in this equation. Let's see, we're looking for the wavelength. We know the frequency is 8, and now we're going to move, it's 88,500,000 because it's 88.5 million hertz, so 88,500,000. There you go. So that's the hertz equals, now the wavelength of light is 3 times 10 to the 8th, or 300 million. I'm just going to say 3 times 10 to the 8th. Now, of course, to solve for a variable in the denominator, I need to get out of the denominator by doing the swap. So I'm going to move the lambda over here. I'm going to put 88,500,000 down here, and let's just see what I get. And looks like what I get is a wavelength of 3.39 meters. So that's a radio station that my wife and I listen to, NPR. He probably don't listen to it, being kids and all that. But the wave, it's almost a 10-foot long wave. Now let's try the next one. What are the 3 primary colors of light? They are red, green, and of course blue. Notice that yellow is not one of them. Why? The question is, why are there only 3 primary colors? That's because, let me switch to my typing mode. Because there are 3 different color sensitive cell types, otherwise known as cone cells, in the retina of our eyes. If there's 4, there'd be 4 primary colors. And those ones are sensitive to red, green, and blue. Now, of the visible frequencies of light, red, orange, yellow, green, blue, indigo, and violet, which have the longest wavelengths? That would be red. Red is long waves, and violet are the shortest. What is the color of light waves with a frequency just a little higher than yellow? So let's look here. Here's yellow. A little bit higher frequency would be green. So that's higher frequency, shorter waves, so the answer is green. What part of the spectrum has wavelengths that are shorter than X-rays? So if we look at the electromagnetic spectrum, X-rays are almost the shortest. The very shortest are gamma. So gamma rays are the shortest waves on the electromagnetic spectrum. Let's keep going here. Whoops, darn it. Okay, now comes the tricky ones here. These are the ones I'm most interested in you being able to do. So here's what we've got. A car that looks magenta in sunlight, which is white light, has a pigment that absorbs which color? So the question is, which color do we have to absorb to turn white light into magenta light? So let's go to a diagram of this. Alright, so here's a diagram showing what's happening. White light from the sun. Remember, white light contains all the colors of the rainbow, but we can pretend that it's just red, green, and blue because that's what our eyes can see. So red, green, and blue light hits the car. Now, if all of them bounced off, if the red, the green, and the blue all went to my eyes, I'd say that's a white car, but that's not what happened. I saw a magenta car. Now, remember, magenta is what you get when you have a combination of red and blue. So it happens, if I look at this car and my eyes see magenta, that's because red light is going into my eyes and blue light is going into my eyes, but green light is not. So the answer is this car absorbs green. So the answer in this case is it absorbs green pigments. What color would the magenta car look in blue light? Well, since it absorbs green and reflects blue, It would therefore look blue. If blue light hit it, since it reflects blue, it would look blue. What color would the magenta car look in green light? Well, since it absorbs green, there'd be nothing left to go into my eyes, so the answer would be, it would look black. What color would the magenta car look in red light? Well, it absorbs green, but it reflects blue and red. Since red is hitting it, it will look red. Red light bounces off of it. What color would it look in yellow light? Now remember, yellow is a combination of what two colors? If you recall, there's a color. So basically what's happening is red light and green light combine to make yellow light. So you can think of it as red and green light are hitting the car, but the green is going to get absorbed, leaving only the red to go into my eyes. The car will look red. Now a shirt has pigments that absorb all the wavelengths that stimulate your red and blue cone cells. What color would the shirt look in white light? Well, therefore, if it absorbs the red and the blue, all that's left is green. The shirt will look green. What color would it look in blue light? Well, since it absorbs blue, we see right here, it absorbs blue, and that's all that's hitting it, it is going to look black. Oops. Black. What color does the shirt look in yellow light? Now let's remember, yellow is a combination of green and red, and since this one absorbs red, it will end up looking green because it reflects the green light that hits it. Grass is green. What colors does it absorb? Well, the fact that grass is green tells me that it absorbs red, and it also, I'm going to change this, it also absorbs blue. Hey, that's it for your homework. I hope you enjoyed it as much as I did. See, it didn't take very long.